Hello, guys. We are GCT students and a team of five. And today we are going to present on the topic poor transition from classroom to career for design thinking laboratory. So now I will start with problem statement. So the problem statement is students who perform well academically struggle to transition into industry roles because classroom learning lacks real world context, continuous skill based feedback, and visibility into industry expectations, resulting in low confidence and poor career readiness. So basically what it means is the first is a real world context. In the real world context, what happens is we have to coordinate with our teams, we have to know the coding skills, but in the classroom the teaching is limited only up to the theory part. So therefore it is not helpful for our coding skills. And the second is continuous skill based feedback. So the classroom evaluation is done mostly based on the exam and the assignment rather than the soft skills. So this feedbacks must be given for the soft skills to be developed further. And the last one is visibility into industry expectations. Most of the students do not know the workplace, do not know the tools, and therefore it leads to confusion of what the companies expect students to do. And this three results in low confidence and poor career readiness. So the low confidence is students feel they're unprepared, they're insecure, and also they're unsure of their abilities. And the poor career readiness means when the students graduate, they lack the practical exposure, industry relevant skills, and this leads to difficulty getting jobs and longer job searching.
Here, we applied rapid prototyping to quickly design and test our solution for the problem. The main issue is that students perform well academically but lack practical exposure. To address this problem, we designed a gamified learning system called Career Quest. Instead of traditional assignment, students learn by completing real world tasks, gaining the experience points, progressing through the levels. The main focus is on experience based learning and the skill development, which directly improves the confidence and industry readiness. The core feature of our idea is that first, mission based real world task. Students complete tasks that stimulate the real world problems instead of just writing the exams. Level progression. They move through a level like a game. For example, intern to junior developer. Based on their performance, this level progression will be happen in our idea. Then skill tracking and feedback. The system continuously tracks their skills and provides a continuous feedback on where they need the improvement. Fourth, achievement and the badges. Student earns badges for completing each and every task, so which increases the motivation and their engagement towards our application. And also, AI Career Assistant was included as a feature in our system. An AI module analyzes the student performance, the suggestions to the student for the improvement, and guides them towards the suitable career roles. Last, streak tracking and coding activity. The system tracks daily practice and coding activity to build the consistency and discipline. These are all the core features of our idea. Moving on to the flow of our system, the students select a mission. By selecting the mission, they want to complete the respective task. By completing these tasks, they can earn the experience points. These experience points will updated as a skill in the system. If enough experience points is gained, they level up. Then AI analyzer can also be used for the better performance of the student, and also it provides a suggestion and improvement for the student development. This cycle continues to help the student gradually becoming a industry ready. Overall, we use rapid prototyping for the quick validating this idea and design a solution that focus on real world learning and the continuous improvement.
Hello all. Now I am gonna explain our initial prototype of the system. This is the main dashboard where the user can track their overall progress. At the top, there is the user profile, the current role, and the XP and the progress to the next level. And the inner career journey section shows progression from intern, junior development, senior engineer, and then to the tech leader. In the activity streak session, it motivates the users to stay consistent by tracking daily performance. We also include achievement points from activities like hackathon, coding contest, and workshop. The screen focuses on motivation and continuous progress tracking. The next is the mission board screen. In the mission board screen, it is the core learning component of our platform. Here, users are given with the real-world tasks like bill logging page and the API integration or deployed to the cloud. The tasks are categorized into easy, medium, and hard levels to support the gradual learning. Users earn XP points for completing each mission, which contributes to their overall progress. The start button allows the users to directly start working on their task. By gaining the XP, they could progress to the next levels. Unlike the traditional theory based learning, this approach focuses on hands on experience and practical skill development. The screen represents the achievement system, which is a core gamification feature used in most of the games. Users earn badges like Bug Slayer, Project Master, and Team Player by completing the task. These achievements encourage users to actively participate in real world activities like projects and collaboration. This increases engagement and motivates consistent learning. The screen shows the skill tree where users can track their skill levels in different areas. Skills like problem solving, coding, communication, system design, and teamwork, and their skills are tracked by using the progress bar. It is categorized, and skills also have feedback such as areas that need improvement. This provides continuous feedback, which is missing in the traditional learning. And the next is the activity stick and the achievement points. The screen focuses on user engagement and consistency. The activity stick tracks how regularly a user completes tasks and engages in the daily learning habit. It also shows users' best streak, motivating them to improve consistency. Below that, there is the achievement point section. The achievement point section for participating in the hackathon, coding contest, and workshops, the points are awarded. The next is the AI Career Assistant, which is the unique feature of our system. In this, the job match will match the current skills with the job roles and give what are the skills we need to gain further and how much match percentage we are to each of the job role. And then next is the resume session in which the user need to upload the resume and it would get the AATS score. The next is the AA mock interview in which the AA conducts the interview, and by the results of the interview, the suggestions are provided by the AA in the feedback session, and for better improvement in the next interview, the tips are given and what are the things to work on are given in the tip section. Thus, this helps the bridge the gap between current skills and the industry requirements.
Hello everyone, I am going to explain the usability testing. In this section, I will present the user feedback we collected and the testing process we performed to improve our system. After rolling out our prototype, we gathered the feedback from our classmates. Some of the feedbacks are here. User A reported that there is no coding platform integration, which limits the practical learning. User B mentioned limited hackathon and real world integration, reducing the exposure to industry experience. User C pointed out that content is repetitive, which may reduce the user interest over time. User Z, User D highlighted the absence of portfolio feature, making it difficult to showcase skills and projects. From these feedbacks, we identified the strengths and area for improvement. The strengths are gamification, clarity, engagement, and usability. The areas for improvements are reduce the repetition, add the coding practice, include the portfolio feature, and improve the real world exposure. Based on these insights, we decided to remove the redundant content, integrate the coding platforms, add the portfolio feature, improve the AI assistant, and enhance the real world task and hackathon participation. Now, moving on to the iterative testing. To ensure the system works correctly, we followed an iterative testing approach. This means we continuously tested, identified the issues, and made improvement, and tested again to refine the system step by step. We performed two types of testing. First one is unit testing. For unit testing, we use white test. It tests individual components and ensure the proper UI behavior like tab switching and model functions. Second, end-to-end testing. For end-to-end testing, we used Playwright. This simulate the real user interaction, verify the complete workflow and navigation. After multiple iteration of testing, we made a several improvements that are better tab validation with content checks and improve the model lifecycle testing and ensure the correct model visibility after the navigation.
Hello everyone, let us see the iterative design of our prototype. This is the player profile. Here the student is represented as a player with a level. Here he is a junior developer. The XP bar shows the progress towards the next level, which helps students clearly understand their growth. Below, we show the career journey path where progression is visualized from intern to software engineers. This replaces traditional mark with visible skill-based growth. Here, we also included the portfolio link and lead code link of the student. Let us see the mission dashboard. In the mission dashboard, instead of theory assignments, students complete real-world tasks like building login page, REST API integration, deploy to cloud, participate in hackathon. Each each task has difficulty level such as it also acts SP reward and status tracking. This helps students applying concepts practically and prepares them for industry tasks. Let us see the batches. This is the achievement section. Student can earn badges such as bug slayer, project manager, team player. Uh, Here, this creates motivation and encourages continuous improvement. Locked achievements pushes students to explore more learning opportunities. Let us see the skill tree. This is the skill tree. The skill tree progress section, it tracks the important skills like problem solving, coding, communications. Instead of marks, students receive continuous feedback and helping them identify strengths and areas for improvement. Let us see the AI career mentor. In this section, it will shows the job matching, resume analysis, and interview preparations. For example, it suggests roles like front end and or full stack developer with match percentage. It also provides a mock interview challenge, helping students practice in a safe environment. In the resume section, the student can upload their resume and see the overall score. In the interview section, the student can participate in mock interview challenge. In the feedback section, the students get feedback. In the tips section, they will receive some recommendations to improve their skills. Let us see the stick sections. This system also tracks the interview performance, daily coding activity, resume score, and learning sticks. This ensures students receive continuous insights into their products. In, here, it shows the activity sticks. Here, the achievement points, which also includes the hackathon, coding context, and the workshops. In the lead code activity, it also shows the stakes, and below that, it shows the person which problems are recently solved. Finally, we came to our conclusions. In our conclusion, our system does not just improve the learning but redesigns the entire student experience. This
Project follows design thinking principles. In the empathy stage, understanding student struggles. In the define stage, identifying the confidence gap. In the ideate stage, gamified learning system. In the prototype stage, career cost interface. These solutions transform learning from passive to active, from mark based to skill based, from stressful to engaging. It helps students build confidence and become industry ready step by step. Thank you.